4.2 continued. The domain and range of the sine and cosine functions. The domain for both can be negative infinity to infinity because the domain refers to the angle of your turn. And once you start turning, you can turn in a positive direction, you can turn in a negative direction, and the turn can keep going forever. And then wherever it stops, that's when you're going to find the sine or cosine. The range for both sine and cosine is -1 to 1 with brackets, because here is cosine goes from -1 to 1 because the cosine is the x coordinate, the sine is the y coordinate, so -1 to 1. Now, if you want to find the values of the trigonometric functions at pi over 4, pi over 4 is also 45 degrees. So sometimes it's helpful to think about these in terms of degrees instead of radians. And as we talked about the other day, to convert from radians to degrees, you multiply by 180 degrees over pi radians, and 180 divided by 4 is 45. Now, one way to do this is to think about a 45, 45, 90 triangle. It's an isosceles right triangle, and I'm going to let this side be 1, which would also make this side 1 because it's equal. Then to find the hypotenuse, I would use the Pythagorean theorem. A squared plus b squared equals c squared. So this is 1 plus 1, which is 2, equals c squared. Take the square root to cancel the square. Normally I would do plus or minus, but since I'm talking about the length of a triangle, it would be just the positive. So now if I have 45 degrees and I want to find the sine, for example, I can use something that you may remember from geometry, SOHCAHTOA. This will help us remember sine is equal to the opposite side over the hypotenuse. So if I want the sine of 45 degrees, I want the opposite over the hypotenuse. So that's 1 over radical 2, and then rationalizing your denominator to get rid of the radical in the bottom gives me radical 2 over 2. If I want the cosine of 45 degrees, I'm going to take the adjacent over the hypotenuse. Adjacent over hypotenuse, it's the same thing. 1 over radical 2, which after I rationalize the denominator becomes radical 2 over 2. If I want the tangent, it's the opposite over the adjacent. So if I want the tangent of 45, it's the opposite over the adjacent. 1 divided by 1 is 1. So that's where I'm going to get these values here. Now, the other three trigonometric functions are just reciprocals of those. So the cosecant is going to be the reciprocal, which is 2 divided by radical 2. And then I rationalize the denominator by multiplying by radical 2 over radical 2. The 2's cancel out, and I'm left with just radical 2. The secant is the reciprocal of the cosine. It's going to be the same thing. The cotangent is the reciprocal of the tangent, and 1 divided by 1 is 1. Now, 2 of our trigonometric functions are going to be even functions, and we talked about even functions previously in earlier chapters. To find an even function, you would be able to plug in a negative here, but you would get the same answer if you plugged in a positive. So that works for cosine and secant. They're both even functions. The odd trigonometric functions are the other 4, because an odd function, when you plug in a negative number, you get the opposite of the sine of t. That's the definition of an odd function. So those 4 are going to be odd functions. So if you wanted the secant of pi over 4, it's an even function, so it should be the same as the secant of pi over 4, which we found on the previous page to be radical 2. If you want the sine of negative pi over 4, it's an odd function, so it would be the opposite of the sine of pi over 4, which we found on the previous page. so it's negative radical 2 over 2. If we want the cosine of negative pi over 4, it's an even function, so it would be the same as the cosine of pi over 4, which we found on the previous page. So it's radical 2 over 2. Okay, so just to review the reciprocal identities, the cosecant is the reciprocal of the sine, the secant is reciprocal of the cosine, cotangent and tangent are reciprocals of each other. Now, there are quotient identities, which were already mentioned, because the tangent is y over x, but since y is the sine and x is the cosine, the tangent is also sine over cosine. And the cotangent would be cosine over sine, since it's x over y. All right, now if you are given the sine of t is equal to 2/3 and the cosine of t is equal to radical 5 over 3, and you want to find the value of the remaining trigonometric functions, well, the cosecant is the reciprocal of the sine, so just flip the 2/3 and you get 3/2. The secant is the reciprocal of the cosine, so just flip what they gave you there, radical 5 over 3, flip it, rationalize the denominator by multiplying top and bottom by radical 5, and you get 3 radical 5 over 5. The tangent is going to be the sine divided by the cosine. So when you divide fractions, you flip and multiply, then you rationalize your denominator by multiplying by radical 5 over 5. And then the cotangent is just the reciprocal of the tangent. So go back to the step before you rationalize the denominator and flip that. And then you'll get this, and that's the reciprocal of the tangent. Now, the Pythagorean identities, you're going to probably want to write these on a note card to keep them handy. You will need them a lot. Sine squared t plus cosine squared t equals 1. 1 plus tangent squared t equals secant squared t. And 1 plus the cotangent squared t equals cosecant squared t. So we can use a Pythagorean identity to solve a problem. Given that the sine of t is 1/2 and t is in radians between 0 and pi over 2, that just means it's in the first quadrant, okay? The first quadrant where everything is positive, because pi over 2 is 90 degrees here. We want to find the value of the cosine of t using a trigonometric identity. So we're going to use sine squared t plus cosine squared t equals 1. We know what the sine is, it's 1/2. So sine squared t plus cosine squared t equals 1. 1/2 squared is 1/4. Subtract the 1/4 from 1. That's how I got 3/4. Take the square root of both sides. Now normally I would do the plus or minus, but because we're in quadrant 1, we're going to forget about the minus because everything in quadrant 1 is positive. And the square root of 3 is the square root of 3, and the square root of the denominator 4 is 2. So the cosine of t is radical 3 over 2.